Hello everyone, today we will be doing chemical energetics, and under that we'll be doing endothermic and exothermic reactions. So first we'll do paper 3, then we'll move on to paper 4. So question 1. Alkylanes are homogeneous series of hydrocarbons which are made by cracking larger alkylane molecules. Polyethane is produced by polymers of ethane. The reaction is exothermic. State the meaning of exothermic. So exothermic is when thermal energy is released in a reaction or when heat is given out. But it's better to write this because it uses more keywords. Figure 4.2 shows the reaction pathway diagram for this reaction. Explain how this reaction pathway diagram shows that the reaction is exothermic. So this is energy, this is progress of reaction, this is our reactants, and this is our product. So we have to know something about reaction pathway diagrams, and in this question it says why is it exothermic. So reaction pathway diagrams usually show the transfer of energy. So they want us to relate it with that. So here we can see that the energy of the reactants is higher or greater than the energy of the product. So that's one of the key features of an exothermic reaction. So they want us to write that. Energy of the reactants is greater than the products. The question is about metals and compounds of metals. Magnesium chloride is produced when magnesium burns in chlorine. Mg plus Cl2 arrow MgCl2. So this is irreversible, as we can see the arrow is one side. Figure 4.1 shows an incomplete reaction pathway diagram for this reaction. Complete figure 4.1 by writing these formulae on the diagram. So this is our reactants and this is our products. So Mg plus Cl2 will be here and MgCl2 will be here. So this shows that it's also exothermic. So explain how this, we already did this question, but just to repeat it, because the reactants have greater energy than the products. So now let's do paper 4, where it focuses more on equilibrium, contact process, Haber process, and how to calculate bond energies. So Haber process is used to manufacture ammonia. The question for Haber process is shown. Equation for Haber process is shown. So this states the state of the element, or like the chemical. So all of them are gas, we can see. So N2 gas plus 3H2 gas, reversible reaction, 2NH3 gas. So now we know it's a reversible reaction. So there might be follow-up questions about equilibrium. So this is delta H, which is energy change. So it's minus 92 kJ. State what is meant by the simple delta H. So delta H means enthalpy change. Delta H for the forward reaction is minus 92 kJ. State why this value shows that the forward reaction is exothermic. So when the reaction is exothermic, delta H will always be negative because it's releasing heat. But when delta H is positive, that means it is endothermic because it's gaining heat. So we can just write delta H is negative. So delta H, or enthalpy change, is basically just the amount of energy released or absorbed during like a chemical reaction. So that's why minus means that the system, or like the reaction, loses energy because it's giving out energy, so it loses its own energy. But when it absorbs energy from the surroundings, it's positive because it's gaining energy from the surroundings. Okay. So this is going to be a bond calculation. It requires a lot of maths, but that's fine. This question is about alkylanes and alkanes. Ethane reacts with chlorine at room temperature to form C2H4Cl2. Here is our chemical reaction for that. C2H4 plus Cl2 arrow, so it's not reversible. C2H4Cl2. The chemical equation for this reaction can be represented as shown. The energy change for the reaction is minus 18 kJmol. So this means it's exothermic. So this is just another way to show chemical reactions and their like bonds. So we can see this is 1 bond, 2 bonds, 3 bonds, 4 bonds. So we can see 4 bonds of CH4, and here we can see there are 4 bonds of CH. Okay. Use the bond energies in the table to calculate the bond energy of bond Cl in kJ or mol. So they give us this table of bond energies, and they'll always give this, but they didn't give for Cl. They didn't give for CCl. So they did not give for this. And we have to find that out using what we have here. So first we need to calculate the energy that breaks the bonds. So this is quite simple. We just have to look at our reactant side. We just have to look at this over here. So let's calculate. First we have CH4, so there's 4 of it. So here we can see for this bond it's 410 times 4, because there's 4 of those bonds, plus double bonds C, that's 610, plus Cl, so that's 240. So they give us in steps, which makes it easier for us. So let's just calculate this, which is 2490. This is the energy needed to break the reactants bonds. Okay. Next, use your answer in step 1 and the energy change for the reaction to determine the energy released when bonds are formed. So for this, we just have to add 2490 with 180, which is the enthalpy change. So that equals to 2670. So we write that here also. So this is our total energy released when the bonds are formed. So now all we're left is use your answer in step 2 and the bond energy values to determine the energy of CCl bond. So here we just have to go back up. Yeah. So we have CH, 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 and CH, and we have CC bond. So that means 410 times 4 bracket plus 350 equals 1999. So now we have the products energy except C and Cl. So then we do 2, the energy released when bonds are formed, subtracted with this energy, which will equal to minus 680. So this would have been our answer, except if we go here, we can see that there are 2 bonds of CCl. So what do? We divide by 2. So 680 divided by 2 is equal to 340. So bond energy is 340. So this is going to be our last question. Ethane is an alkylane which reacts with bromine as shown in the equation. Part of the energy profile diagram is shown. So this is incomplete. The reaction is exothermic. Complete the energy profile diagram for this reaction. Includes position of products, an arrow to show the activation energy labeled as A, an arrow to show the energy change for the reaction. So activation energy is the minimum amount of energies the molecules or particles need to acquire for a reaction to happen. So that should be known. And energy change is just what I said, the delta H. So they give us a hint here and they say it's exothermic. So that means that our products will have less energy than the reactants. So they give us here the reactants is C2H4 plus Br2. So since we have to show our activation energy, we're going to have to make it like a hump. So like this. And then it goes like this. And then here will be our products. So C2H4 plus Br2, that's easy. That's just this. Okay, so now we have to show activation energy and enthalpy change. So activation energy would be this, so this arrow going up all the way here. Let's label it as A. And enthalpy change, which is energy change, will be just this, so it goes downwards. So let's just write delta H there. Yeah, so that is it for today's video. Thank you guys for watching. I hope you learned something.